If we consider circular motion and the two vector components, vectors, velocity and acceleration. Velocity and acceleration are both vector quantities, i.e. they have a magnitude and a certain direction. When describing circular motion, it is sensible to take components in two directions. Now the two directions are, one, the radial direction, which is along the radius, and two, the transverse direction, which is at right angles to the radius. In this one, away from the centre of the circle is taken as being positive, and this one anti-clockwise is taken to be positive. So consider the diagrams on the following page, and we're going to look at both velocity and acceleration in separate diagrams. So looking at velocity, so here we've got a particle, and the outwards velocity would actually be equal to 0, and we've already discovered that v is equal to r omega, where omega is the angular speed, which is the rate of change of this angle with respect to time, the angle being measured in radians. So the radial component is equal to 0, i.e. there's no speed going outwards like that, and the transversal component would have to be v is equal to r omega. This is called angular speed. For acceleration, then we have something slightly different. The radial component is a will be equal to minus r omega squared. So we've got this, although it's pointing outwards, because it's negative, it's actually acting towards the centre of the circle. And the transversal will be r dot omega squared. Now what is r omega with a dot on? What does that dot mean? Well, that dot means angular acceleration. It's a differential of this one here. So if you can imagine a particular particle travelling in a straight line, to make it move in a circle, there needs to be some sort of acceleration directed towards the centre, i.e. so to make it move in a circle, this acceleration would have to be a constant. Note, if the particle is travelling at a constant speed, then the transversal component of acceleration, i.e. this one, would have to be equal to 0. So all we would need is this one here acting towards the centre of the circle. So for circular motion with constant speed, circular motion at a constant speed, there is no transversal component of acceleration. If we look at this diagram here, we would have acceleration acting towards this way, and we'd have a speed here which would be r omega, omega being the rate of change of this angle, the particle moving around in this direction being positive. So if we want to find the magnitude of this acceleration, remember outwards is positive, so the radial component of acceleration, you can actually write it in terms of v and r. We know that v is equal to r omega, and therefore omega is equal to v divided by r. Now a is equal to r omega squared, which we just established in the previous part, and then if we replace omega with v over r from here, we're going to have the r v over r all squared. This r will cancel, and you'll be left with v squared over r. And this magnitude will have to be directed towards the centre of the circle.